A riparian buffer is a vegetated area near a stream, usually forested, which helps shade and partially protect a stream from the impact of adjacent land uses. It plays a key role in increasing water quality in associated streams, rivers, and lakes, thus providing environmental benefits. With the decline of many aquatic ecosystems due to agricultural, riparian buffers have become a very common conservation practice aimed at increasing water quality and reducing pollution. Benefits: riparian buffers act to intercept sediment, nutrients, pesticides, and other materials in surface runoff and reduce nutrients and other pollutants in shallow subsurface water flow. They also serve to provide habitat and wildlife corridors in primarily agricultural areas. They can also be key in reducing erosion by providing stream bank stabilization. Water quality benefits: intercepting sediments, nutrients, key to counteract eutrophication in downstream lakes and ponds, which can be detrimental to aquatic habitats because of large fish kills that occur upon large-scale eutrophication. Intercepting pesticides: riparian buffers keep chemicals that can be harmful to aquatic life out of the water. Some pesticides can be especially harmful if they bioaccumulate in the organism, with the chemicals reaching harmful levels once they are ready for human consumption. Bank stabilization: this is important because erosion can be a major problem in agricultural regions when cut banks can take land out of production. Erosion can also lead to sedimentation and siltation of downstream lakes, ponds, and reservoirs. Siltation can greatly reduce the lifespan of reservoirs and the dams that create the reservoirs. Habitat benefits: provide habitat. Riparian buffers can act as crucial habitat for a large number of species, especially those who have lost habitat due to agricultural land being put into production. Increase biodiversity: by adding this vegetated area of land near a water source, it becomes a prime location for species that may have left the area due to non-conservation land use to re-establish. With this re-establishment, the number of native species and biodiversity in general can be increased. Buffers acting as corridors: buffers also serve a major role in wildlife habitat. The habitat provided by the buffers also double as corridors for species that have had the habitat fragmented by various land uses. Shading water: the large trees in the first zone of the riparian buffer provide shade and therefore cooling for the water, increasing productivity and increasing habitat quality for aquatic species. Large woody debris: when branches and stumps fall into the stream from the riparian zone, more stream habitat features are created. Carbon is added as an energy source for biota in the stream. Economic benefits: increase land value. Often people who purchase land for recreational use are willing to pay more if there is more wooded area located on the land. Produce profitable alternative crops. Vegetation such as black walnut and hazelnut, which can be profitably harvested, can be incorporated into the riparian buffer. Increase lease fees for hunting. The increased habitat means that the land will be more sought after for hunting purposes. Buffer design: a riparian buffer is usually split into 3 different zones, each having its own specific purpose for filtering runoff and interacting with the adjacent aquatic system. Buffer design is a key element in the effectiveness of the buffer. It is generally recommended that native species be chosen to plant in these 3 zones, with the general width of the buffer being 50 feet on each side of the stream. Zone 1. This zone should function mainly to shade the water source and act as a bank stabilizer. The zone should include large native tree species that grow fast and can quickly act to perform these tasks. Although this is usually the smallest of the three zones and absorbs the fewest contaminants, most of the contaminants have been eliminated by Zone 2 and Zone 3. Zone 2, usually made up of native shrubs, this zone provides a habitat for wildlife, including nesting areas for bird species. This zone also acts to slow and absorb contaminants that Zone 3 has missed. The zone is an important transition between grassland and forest. Zone 3. This zone is important as the first line of defense against contaminants. It consists mostly of native grasses and serves primarily to slow water runoff and begin to absorb contaminants before they reach the other zones. Although these grass strips should be one of the widest zones, they are also the easiest to install. Streamed zone. The streamed zone of the riparian area is linked closely to Zone 1. Zone 1 provides fallen limbs, trees, and tree roots that in turn slow water flow, reducing erosional processes associated with increased water flow and flooding. This woody debris also increases habitat and cover for various aquatic species. The National Agroforestry Center has developed a filter strip design tool, which is a GIS-based computer program for designing vegetative filter strips around agricultural fields that utilizes terrain analysis to account for spatially non-uniform runoff. Species selection. In Zone 1, cottonwood, bur oak, hackberry, swamp whitetail, Siberian elm, honey locust, silver maple, black walnut, and northern red oak. In Zone 2, Manchurian apricot, silver buffaloberry, carragana, black cherry, choke cherry, sour cherry, Peking cotoneaster, Midwest crabapple, golden currant, elderberry, Washington hawthorn, American hazel, Amma honeysuckle, common lilac, Amma maple, American plum, and skunk bush sumac. In Zone 3, western wheatgrass, big bluestem, sand bluestem, side oats, grama, blue grama, hairy grama, buffalo grass, sand lovegrass, switchgrass, little bluestem, Indian grass, prairie cordgrass, prairie dropseed, tall dropseed, needle and thread, green needlegrass. Managing forests in riparian area. Logging is sometimes recommended as a management practice in riparian buffers, usually to provide economic incentive. However, some studies have shown that logging can harm wildlife populations, especially birds. A study by the University of Minnesota found that there was a correlation between the harvesting of timber in riparian buffers and a decline in bird populations. Therefore, logging is generally discouraged as an environmental practice, and left to be done in designated logging areas. Conservation incentives. The Conservation Reserve Program, a farming assistance program in the United States, provides many incentives to landowners to encourage them to install riparian buffers around water systems that have a high chance of non-point water pollution and are highly erodible. For example, the Nebraska system of riparian buffer payments offers the following. Annual rental payments equals $62 to $116 per acre per year. Sign-up bonus, upfront payment of $10 per acre per year for the life of the contract. Payments for 90% of costs for trees, shrubs, grass seed, site preparation and planting. 10 to 15-year contracts. Eligible areas. Up to 180 feet average width along each side of a continuous or intermittent stream. Strips of grass, shrubs, and/or trees can be used. Planting done by the local natural resource districts. These incentives are offered to agriculturists to compensate them for their economic loss of taking this land out of production. If the land is highly erodible and produces little economic gain, terrain, it can sometimes be more economic to take advantage of these CRP programs. Effectiveness. Riparian buffers have undergone much scrutiny about their effectiveness, resulting in thorough testing and monitoring. A study done by the University of Georgia, conducted over a 9-year period, monitored the amounts of fertilizers that reached the watershed from the source of the application. It found that these buffers removed at least 60% of the nitrogen in the runoff, and at least 65% of the phosphorus from the fertilizer application. The same study showed that the effectiveness of the Zone 3 was much greater than that of both Zone 1 and 2 at removing contaminants. Long-term sustainability. After the initial installation of the riparian buffer, relatively little maintenance needs to be performed to keep the buffer in good condition. Once the trees and grasses reach maturity, they regenerate naturally and make a more effective buffer. The sustainability of the riparian buffer makes it extremely attractive to landowners, since they do relatively little work and still receive payments. Riparian buffers have the potential to be the most effective ways to protect aquatic biodiversity, water quality, and manage water resources in developing countries that lack the funds to install water treatment and supply systems in mid-size and small towns.